All right, everyone. So, hello, and then welcome to Mclean 360. Um, so in today's tutorial, we are going to look at um, um, you know, strength of materials. I'm going to review some couple of questions with you. Okay. So, first of all, I want us to look at the concept of shear force and then bending moment diagram. Okay. All right. So I want us to start off. So I want us to look at the shear force and the bending moment diagram. All right. So I'm going to put a question there and we will quickly try and draw the shear force and the bending moment diagram. Okay. All right. Um okay. So um okay, I'm coming. I just want to give us a question and then we just solve it together. After that, I will do um the principal stresses with you. Okay, so basically, can you see my screen? Hello, please, can you see my screen? Okay. All right. So first of all, I want us to look at um some concepts. Okay. Sorry for the delay. I think I was having a challenge with my screen. So I hope everybody can see this question. All right. So let's say you have been given a question like this, and then you have been asked to draw the shear force and then the bending moment diagram. Okay. So how can you solve this problem? Quickly, let's do this together. Um, First of all, you are going to start from your statics and then solve for the reactions. Okay. So I'm not going to waste time on that because I know that you understand equilibrium of rigid bodies. So I will go straight forward. First of all, find the reactions at the support. So when you come to this point here, we have a pin joint, or which is also called a hinge joint. Okay, so you will try and find the reactions. So first of all, you sum forces in the x direction, and then you sum forces in the y direction, and then you sum moment. Kindly give me some few minutes. Okay, so you first of all sum forces along the x to be 0, but then like I said, B is a hinge, so it has two reactions. So there is one reaction along the x, and then there is another reaction in the y direction. Now D is a ruler, so there is only one reaction, so dy. Okay, now what you have to do is that when you get to this point, summation of forces bx will be 0 because there is no force along the x. Now you have summation of forces in the y. Every force going up should be positive, equal to 0. So minus 20, this 20 is coming down, and then positive by because by is going up, and then minus 40 because it's coming down, and then plus dy because it's going up, should be equal to 0. So from here you can say that by plus dy must give us 40 plus 20 is 60. Let's call this equation 1. Now at this point you have to some moment, because you have two equations but then you have two unknowns. Sorry, you have one equation but two unknowns, so you need an extra equation which will be coming from the moment. So we will some moment about point, let's say b clockwise is positive should be equal to 0. And then basically what we have to do is, if you take the 20 kilonewtons about point b, it's going to create a an anti-clockwise moment. So that is negative. We said clockwise is positive. So basically it's going to be minus 20. So minus 20 multiplied by 2.5. And then so that is it. And then you take 40 kilonewtons about point B, it will create a clockwise moment. This 40 kilonewtons about point B to create a clockwise moment. So 40 times 3. So 40 times 3. And then finally dy. Dy will create a moment which is going to go counterclockwise. So negative, because dy is going to create counterclockwise about point B. So that one too will be negative. Now so minus 5 dy should be 0. Now you have to solve for dy. So you can say that dy, so you can say that from here 5 dy is equal to 5 dy is equal to, so let's pick our calculators, minus 20 multiplied by 2.5 plus 40 multiplied by 3. So that gives us 70. Okay, that gives us 70. Now this 70 is actually okay, so 70, so it means that dy will be what, 70 divided by 5, and 70 divided by 5 is going to be what, so 70 divided by 5, 14. So dy is 14 kilonewtons. Dy is 14 kilonewtons. Now after solving for dy to be 14 kilonewtons, then you substitute this value into equation 1. So we can say that by will be 60 minus dy, which is what, 60 minus 14, and that will give us what, that will give us 12, 60 minus 14, so that is 46 kilonewtons. So by is 46. All right, so that is the statics. Okay, now any question up to this point? Any question up to this point, please? Okay. So now from here, what you have to do is that you draw it again. But this time around, you indicate all the reaction forces. So it's going to be something like this. You draw the whole beam again. So now we have 20 kilonewtons. And we have um so we have by here, but by is what? 46. So here is 46 kilonewton. And then we have at point C 40 kilonewtons. So we have 40 kilonewtons. And then finally dy, which is what? Dy is 14. So how can you draw the shear force and the bending moment diagram for this? It's very simple. So first of all, let's try and draw this. Okay. Now let's assume that there is a line here which is 0. And let's call this V, which is shear force per unit kilonewtons. Okay. Now this is what we are going to do. First of all, we would begin from point A. Okay. Now this is your 0. So I want to teach you how to do this. You will start here. Okay, let me go back to the diagram. So this is what we are going to do. Stand between A and B. So we are going to, okay, so we will start from the first point and then we will finish at the last point. You will stand at A and then cut through here. So if you cut through here, okay, let's say you make a cut like this. Now from here to here, let's call that distance X. Okay. All right. Now after cutting, you will get something like this. Let's say you have this as X. And then you have your 20 kilonewton here. So this distance here, let's call it X. Okay. Now what you have to do is that this distance X which you have here, you actually have a certain moment and then a certain shear force. So this is how you are going to do it. Whenever you draw this, let me try and see if I can show you this. Please, this is not for you. I just want to show you something. So I just wanted to pick something here, but this is not for you. Okay. So please, so there is something which you have to know here. Now, I want everybody to watch this carefully. Look at where I have taken the section. I have taken the section on this side of the beam. So it means that the shear force is positive in this direction, but bending moment, or let's say the internal force, will be in this direction. Okay, that's all. So basically, when you do the cut, the shear force will come down and then the moment will go the other way around. So now let's do it together. Let's sum forces going up to be 0. Let's say that this portion is in equilibrium. So minus 20 will come down, and then minus Vx will also come down to be 0. Now this means that Vx is nothing but 20 kilonewton. So let me bring everything which I'm doing here, let me bring it down. Oh, okay. So what happens is that okay, so Vx is 20. What does this mean? It means that if we start from x equals 0 here and go through along x, at any point in time, Vx is 20. So it means that at any point in time, when you move from, no, I think Vs is minus 20. Vs is minus 20, right? Because if you make Vs the subject, Vs is going to be minus 20. So it means that when you move along the beam from A to B, okay, so from A to B, whilst you are moving along from x equals 0 till you get to this portion, the shear force function was a constant of -20. So you come to the graph, and then so you come to the graph and then locate -20. All right. So -20 is, let's say, something somewhere here. It means that your shear force was a constant from here to here. It was -20 throughout. So this one is -20. Okay. So we are done with the first part. Now let me teach you one thing that you can do. Before we look at the shear force, before we look at the moment, let's do the shear force for all of them. But then we will come back to the moment. Or okay, let's do the moment together. Whilst we do the shear force, let's do the moment together. Okay, so we are done with the first part of the shear force. Now let's look at the moment. So let's assume that this is also bending moment in kilonewton meter. Okay, and then our zero line is this line. Now, who can tell me what is happening here? Now, if we solve for moment, let's solve for moment. So summation of moment clockwise is positive, should be 0, because this is in equilibrium. So it means that this mx is coming counterclockwise, so it's going to be negative mx, and then the 20 kilonewtons is going to also come counterclockwise. So the moment that the 20 kilonewton creates about this section xx is going to be -20 times x. Okay, in other words, the moment is given by -20x. Now I want to teach you a trick here. Please, I want to teach you this trick. Whenever you have movement, it is whenever you want to get movement, integrate the shear force with respect to x. If you integrate shear force with respect to x, you get moment. Okay, whenever you integrate shear force with respect to x, you get moment. So in actual fact, what happens is that from this one, all you have to do is to integrate. So if the shear force was -20 and you integrated it, you will get what? -20x, right? If you integrate -20 with respect to x, you will get -20x. Okay, so even if you don't do the moment and you just integrate the shear force, you will get the moment. I hope it's clear. So it means that, now watch this, it means that whilst we were moving from x equals 0 to x equals so along the beam from x equals 0 until x equals 2.5, the moment function was a slope, a straight line with a slope, and the slope was what? Do you remember this equation? Y equals ms plus c. So if you remember this equation, y equals ms plus c, that is the same thing here. This time around, the y is the m of x, that is the moment function, and then the -20 that you see is like a slope, and the x plus c and the C is the intercept, or at C is the point where the line cut the y-axis. So if C is 0, then it means the line cut the y-axis at 0, but then it has a slope of minus 20. So, and then I want you to understand that whenever the slope is negative, so whenever the slope is negative, you have something like this. And then whenever the slope is positive, so whenever the slope is positive, you get something like this. Now this one is minus 20, okay? The moment is what? Minus 20x. That means that you have a straight line with a negative slope. So it will become something like this. So all what you have to do is to come to the moment function, and then you draw a negative. So you are going to draw a straight line, but the straight line is going to be negative. So something like this. And then it will cut at the point where, so this is like the slope, and at this point where it cut it, the slope is actually minus 20. Okay, so this is your so this is the first part of your moment. Okay, so now we are going to do the same thing, but we will come and stand at okay, let me clean this one. Any question up to this point? Any question up to this point? Now let me do the second one. Okay, so for the second one, you stand between B and C, and then you cut through so you are going to cut through B and C, okay, and then you call the whole of this distance here X. Is that right? Okay, so this is how you are going to do it. You know that there is a force which is here, so you know that already there is a force which is here, and that force is By, which was what? By was 46. So this is going to be 46 kilonewton. Now let's look at something here. If you take a section and cut, this is what you are going to see. So you get the beam here, all right. Then from here you have your 20 kilonewton here, okay, and then there is a certain 46 here. Now the distance from here, so the distance from here all the way up to this point is X. But let's not forget that whenever we do the cut, so whenever we do the cut will be following this principle here. Okay, so which means that shear force will come down like this as Vx, and then movement will go that way. Okay, so this is shear force, this is moment. Okay, now let's sum forces again. But you see from the diagram, the distance from 0 to 46 is what? The distance from 0 to 46 is actually 2.5 meters. So if from 20 to the section is x, and then from here to here is 2.5, then we must so we can say that this one will be what? X minus what? 2.5. all right, so basically this is 2.5. So we expect that this point will be what? S minus 2.5, right? All right, so summation of forces, every force going up is positive, should be equal to 0. We have minus 20 going down. We have plus 46 kilonewtons going up, or let's say 46. Vx is coming down, so minus should be equal to 0. Now if you look at this together, then we can clearly say that Vx is going to what? So from here we can say that Vx is going to be minus 26 plus 46. So minus 26 plus 46. Sorry, minus 20 plus 46. And that is 26. So it means that Vx is what? So Vx is 26 kilonewton, right? Vx is 26 kilonewton. Okay, so now that we have Vx, it means that when you come here, back to the shear force, when you come here, it means that from this point here, from B to C, the shear force was what? A constant, which was what? 26. Okay, so the shear force was a constant, which was what? 26. But you realize that we are on 0. I'm sorry, we are on minus 20. So if you want to get to 26 and then you are at minus 20, it means even if you add 20, it will send you to 0. So in effect, you come up by 6, right? Okay. So what I'm trying to say is that you are going to come up 6. Is it 26 or minus 26? Okay, let me check again. Minus 20 is coming down, and then 46 is going up, so plus, and then Vx is coming down, so minus. So you basically have to send the minus Vx to the other side. Okay, and if you send Vx to the other side, it will just be positive, and 46 minus 20 is 26. Okay, So what we are doing is correct, please. So it means that this one here will be 20, here will be 6. Okay, here will be 6, because if you are at minus 20 and we add 20 to you, so minus 20 and we add 26, actually you end up getting 6, and it maintain this throughout. Okay, okay, thank you, Emmanuel, thank you. All right, now, so this is our shear force at this point. Let's look at the moment. Let's look at the moment. So let's look at the moment. Now, I'll give you a shortcut, but I will prove it again to let you know. Let's sum moment. Let's try and sum moment. Positive is clockwise equal to 0. Let's sum moment about the section XS. So we have MX already, and that one is going counterclockwise, so minus. So we have minus MX, and then we have, okay, so 46, and the moment arm is X minus 2.5, and then it is going at a certain point, it's clockwise actually. 46 is clockwise, so 46 multiplied by X minus 2.5 plus 46 multiplied by X minus 2.5. And then 20 multiplied by X, but then it's going to go counterclockwise, so minus 20X should be what? Should be 0. So if you rearrange, we can say that MX will be 46X minus 46 multiplied by 2.5. 115. Right? And then minus 20X. So MX is going to what? So MX, what is MX? Okay, so it will be 26X minus 115. So basically, this is the moment for the section from but what did we do? You see that, watch this everybody, we took the cut between B and C. So this time around, X will be running from X equals 2.5, and then So x is actually between 2.5 and then 5.5, because if you look at the distance from here to B, that is 2.5, and all the way up to C is 3, but we have cut here. Okay, so the x that you are interested in will be 2.5 and then 5.5. So now let's look at this. At x, so at x equals 2.5, let's see what will happen. At s is equal to 2.5, the moment will be what? 26 multiplied by 2.5 minus 115. And what is this? So we get okay. um I want us to look at something here. With the second one, so mx is counterclockwise, okay, plus 46 clockwise, okay, 20x, okay. um okay, let me check something here. So we got minus 50, right? So okay, minus 50. So it means that when we were dealing with the oh yeah, so what this means is that, guys, here I'm coming. I think there is a mistake somewhere. There is a mistake somewhere. That's why I am having issues here. Guys, we made a mistake somewhere. For the first one, the moment was minus 20x. So the minus 20x here, at x equals 0, we will get 0. But at x equals 2.5, we have to calculate, because if you look at this, x is running from 0 here, but then it will come at x equals 2.5 here. So if you put 2.5 into the moment, I think I didn't do that. If you put 2.5 into the moment, you get minus 20 multiplied by 2.5. And that would have been minus 20 multiplied by 2.5. So that would be minus 50. So please, I'm sorry for this. This one, the first part is supposed to come here as minus 50. Okay? It was supposed to come here as minus 50. I think that is why I didn't understand the answer that we got. Because even if the second one, watch this, with the second one, if we do at x equals 2.5 and put it inside, you see that we are getting minus 50, which is true, because at x equals 2.5 is nothing but at x is 2.5. This is this at point B. So even if you use the second one and use at x equals 2.5, you see that you are getting the same minus 50. Now, if you want to get the moment at C, we'll use at s equals 5.5. So it's going to be 26 multiplied by 5.5 minus 115. And what is that? 26 multiplied by 5.5 minus 115. So that is 28 kilonewton meter. So it means that you will come here and illustrate 28. So basically you have a straight line with a slope of positive 28. Okay, so you come here, this is point C, but it is actually 28, which means you come all the way and draw a line until you get to 28. Okay, can you hear me, please? Can you hear me? Can you hear me? Please, can you hear me? Can you hear me now? All right. And then I think that there was a mistake here, because the shear force that we calculated, we got 28. So I think we were supposed to use this one here as 28. 26, sorry. 26 kilonewton. Okay. Now, okay. Um, let's do the last part. Let's do the last part. So for the last part, you stand between. So you stand between C and D, and then you cut. So you come and stand here, and then cut. Now, if you stand between C and D, and then you cut, you realize that so now X is varying from all the way here till we get here. Okay. Um so this is your X, and then at point B, there's a force of, or there is a load of 46 kilonewtons at point B. So there is a certain load here which is 46 kilonewton, and then so yeah, okay. I think it would be best if I draw that one separate. Okay. So so let's look at the shear force. To be 0. So we have minus 20 coming down. We have plus 46 going up. We have minus 40 coming down. And then there will be shear force here. So the shear force here will come down as Vx, and then movement will go this way, just like how we have been doing it. So this one, shear force will come down and movement will go that way. So minus Vs should be equal to 0. So from here we can say that our Vx is going to what? Minus 20 plus 46 minus 40. And that is what? Minus 14 kilonewton. All right. So that is minus 14 over there. So this means that we will go back to the diagram, and then for the last portion, we are going to say it is minus 14. So it's going to be coming down here, minus 14. That's all. So this one is minus 14. So don't subtract it from anything. When you calculate, you just put it there. Okay. So it means that your shear force is something like this. Okay. At this point, it was negative, but at this point, it was positive, and then at this point, it was negative. So this is your shear force diagram. Now, for your movement, the last time, for this time, you will do the summation of movement again. Now, let's see what you are going to get. So let's sum movement again. Clockwise is positive to be 0. So minus ms, and then okay. So watch this carefully. We are saying the distance from here to here is x, but then this distance here is 2.5, and we also know that this distance from here to here is 3. So the question is, if this is 2.5 and this is 3, then this small distance here will be what? We know that that distance there will be what? X minus 2.5 plus 3, which is what? 5.5 meters. So we can start from the 40 kilonewtons. You see that that moment is going to be about the section it is going to be anti-clockwise, so minus. So minus 40 times x minus 5.5. Okay. And then you have the by, which is the 46 kilonewtons. And then that one is going to what? So about the section, because this one is 2.5 from here to here, is 2.5. Now if I want to get this distance here for the 46 kilonewton, that distance is going to be x minus 2.5. Okay, because I know that this distance from here to here is 2.5. So if I am interested in from B to where the x is, then it will be what I know minus what I don't know. So if I subtract this one from this, that is x minus 2.5, I'll get here. But if you are standing at C, the total distance for you will be 2.5 plus 3, which is 5.5. So if you have this small space here, that one will be what? X minus what? 5.5. I hope the concept is clear. So for the first force, which is the 20 kilonewton, it is going to be about what? X. Okay, that's the distance from where the section is. So now basically it's going to be so we have done for the 40. Now let's do for the 46. It's going to be 46 multiplied by s minus 2.5, but that one is going to be clockwise. So 46 multiplied by s minus 2.5, but then it's clockwise. And then finally the 20 kilonewton is coming down, and that one is going to be anti-clockwise, so minus 20x should be equal to 0. All right, so let me go over this again quickly. for the 40 kilonewton is going to be 40 multiplied by s minus 5.5, which is clockwise, so positive. Then the 46 kilonewton is anti-clockwise. Sorry, that one is also clockwise. The 46 kilonewton is also clockwise. Okay, but the 20 is anti-clockwise. All right, so m of x will be equal to whatever is here. So we have minus 40x plus what? 40 multiplied by 5.5, 220, and then what? So plus 46x minus 46 multiplied by 2.5, which is 115, minus 20x. So m of x is going to what? Minus 46 plus, sorry, minus 40 plus 46 minus 20. So we are looking at all the x. So that is minus 14x, 220 minus 115. So 220 minus 115. So that will give us what? Plus 105. Okay. Any question up to this point? Okay. So what are we getting? Now watch this. We have cut between x from x, so from C and D. So C and D is going to be from x equals, so x is between 5.5 and then 7.5. So x is between 5.5 and then 7.5. So now let's do x equals 5.5 and see what will happen. Put 5.5 here. Minus 14 times 5.5 plus 105. Did you see that we are getting 28 kilonewton again, which is confirming that yes, the moment at that section is exactly 28. Okay, so you see that even if we use 5.5, we are getting 28. Now let's put 7.5 there. It will be minus 14 times 7.5, then plus 105 and this is what? So minus 14 multiplied by 7.5 plus 105. Oh, that is 0. It means that at the last point, the moment is 0, which means our moment will come back all the way here at 28 and come to 0. So that is it. So at this point in time, this one was negative moment, but this one was positive moment. And the maximum moment occurs at C. So this is what we call the critical moment. So if I give you a question and I have asked you to calculate the okay, we have minus 50 here, but then that is in the negative direction. Okay, so this is the shear force and the bending moment diagram for the question. So first of all, what did we do? We solved for the reaction at the support. After solving for the reaction, then we draw the free body diagram. Then we take our time and take each section. Okay, then we get the shear force and then we get the bending moment. But you have to always remember this convention. Any question up to this point, please? Any question? Is there any question? Any questions up to this point, please? Any question up to this point? Okay. So that is it for you. Um I wanted to look at I wanted us to look at the principal stress. Okay. All right. Um Okay, I think so. Let's say you have been given a question like this. So how can you solve this problem? Um. Okay. So this question. All right. Can you all see? I'm sure you can all see it. Okay. Okay. So from for this question, you have been given a point in a structural member which is subjected to plane stress. Okay. And then it says that there are normal and shearing stresses on horizontal and vertical planes through the point as shown in this figure. You are to use the stress transformation equation to determine the normal and shearing stresses on plane AB, and then the normal and shearing stresses on CD, which is perpendicular to AB. Show that the stresses on plane AB and CD using a small element, whatever it is. Okay, now let's look at how you can solve this question. There is a general um, nomenclature about this. I want you to write this one down. So whenever you have a question like this is how it always goes. Always. It goes like this all the time. If the x is in this direction, it is positive. If the x is in this direction, it is positive. But if the x is going against this direction, for instance, if you see that the x is coming inside, then it is negative. Okay. Also, if the y is in this direction, this is positive. That is the nomenclature. If y is in this direction, then it's positive. But then if the y goes inside or opposite to the box, then that is going to be negative. Finally, the shear stress tau xy will always point to the corners. Take notice, the shear stress will always point to the corners. And then you have the top right corner, and then we have bottom left corner. So this is a trick. This is a trick to always do if you have the shear force. So if you always want to know which is positive, quickly draw this here. That is for the shear stress. If the shear stress is not meeting at the corners, let me do it again. Draw the shear force like this. Okay. We are saying that always the x is positive in this direction, the y is positive in this direction, and then the shear stress will always meet at the corners. So tau xy all the time. So if you see that it is the other way around, then it's negative. That's all. So for this question, what do you think sigma x is? Is it going to be positive 80 megapascal or negative 80 megapascal? What do you think? Write it in the box, the comment box. What do you think is going to be? Okay. I'm waiting for your answers. Is it positive 80 or negative 80? So it's going to be positive because the x is coming outside, right? Now, how about the y? The y, is it positive 100 or negative 100? So the y will also be minus 100 megapascal. Any question up to this point, please? Any question up to this point? Any question up to this point, please? So we are going to use some formulas to calculate the principal stresses. Now let's calculate the principal stresses. How about the shear stress? So the shear stress is also going to be what? If you look at it carefully, the shear stress tau xy, because the shear stress is not meeting at the corners, but then it is meeting, so it's not meeting at this side, rather you can see that they are meeting at this side, so that will be negative, so minus what, 60 megapascal. Okay, so all right, so the x is positive, the y is negative, and the tau sy is also negative. So now let's calculate the stresses. All right, so now let's calculate the stresses. I'm going to I'm going to use this axis. I'm going to use this axis, please. So what this means is that along this axis is positive. Along this axis is positive. Sorry, normal. So this is the normal axis, and this is the tangential, and this is the y-axis. So when we say the normal, we are trying to talk about this line here. It is always normal. So let me give you a simple example of what I'm talking about. All right, so this is what we are trying to say. Okay, this is actually the normal. Forget about the formulas. I'm not going to prove any formula. I just want to show you something. So all the time, this is the normal. So if you want to calculate the normal, you will use this small triangle here. Okay, and then the tangential will move along that axis. Okay, so this is tangential, this is normal, and this is the y. So it means that if you take the first portion, which is AB, okay, so if you take the first portion, which is AB, this is what you see. Okay, so basically this is what we are trying to say. If you come and stand at AB here, okay, if you come and stand at AB here, this is AB, this line AB here, okay, So if you bring that AB here, let's say that this is the AB. We are saying that there is an axis which is normal to AB, and then there is the tangential, okay, and that tangential is where AB is acting. So there is going to be a certain shear force along that tangential, okay. But how did we know that this angle here is 42? It's very simple. If this is normal to this plane and then this is 48, so let me go back. We are saying that so this angle here, so we are saying that this angle here, if I have, so this is AB, okay. If I take this AB and draw a perpendicular to this one, okay, I know that I have an angle which is like basically saying that if I draw a horizontal line, okay, so watch this. The angle that this one makes here is 48. It means that if I come here, it will still be 48, but this is perpendicular to this, therefore this must be 42. So that 42 plus 48, we get 90, okay. So that is why this side is 42 here. Now what we are going to do is that we will use the stress transformation formulas, okay. We will use the stress transformation formulas. But then first of all, how do I get the normal? So the formula for the normal is given by, let me write the formula and then we use it together. So this is the formula. If you want to calculate for the normal, this normal, if you want to calculate for this one, there's a formula, okay. If you want to calculate for this normal, and it's given by that. So sigma x, we got 80. Yeah. So sigma x, we got 80. Now theta is going to be 42, and then plus sigma y, we got minus 100. So minus 100 sine squared 42 plus 2 tau xy, the shearing stress was minus 60. So sine 42 cos 42. And what is that? So our normal stress is going to be so it's going to be 80 multiplied by cos 42 squared plus or minus 100 multiplied by sine 42 squared plus 2 times minus 60 multiplied by sine 42 multiplied by cosine 42. So what do you get? So we get the normal to be 60 point what? Minus 60.26. So minus 60.26 megapascal. So we've been able to get this component, which is the normal. Now let's calculate this one, the tangential, the shear stress between the normal and the tangential. There's also a formula for that one. So for the stress transformation, I just want you to understand the formulas, because I cannot prove the formulas and you don't even need the proof, because all the formulas will be given to you directly. There is another formula which we can use. Maybe let me write that one too. So there is this formula here which we could have used to calculate the normal. Okay, but if you want to get the tangential, the formula that you have to use is this. Have you seen these equations before? Please, have you seen these equations before? Okay, so what I'm trying to say is that if you want to calculate for the normal, you can even use this formula. But this one will help us to get the shear stress between the N and the T, which is the normal and the tangential. Let's calculate that one. It's going to be minus sigma S, which is 80, minus sigma Y, which is minus 100. So plus 100 divided by 2 sine 2 theta. So 2 times 42 plus tau sy, which is minus 60. So minus 60 cosine 2 times 42. Okay, so basically we can calculate this as so we have minus 80 plus 100 divided by 2 sine 2 multiplied by 42 minus 60 cosine 2 multiplied by 42. So I think that I think in fact we let me check this. Let's use the long one because I don't know why we are getting. So let's look at the long one, this one. So minus sigma s is 80 minus 100. So sigma y is minus 100. So here will become plus. So sine 42 cosine 42 plus tau xy, so plus tau xy, tau xy is minus 60. So minus 60 cos squared 42 minus sine squared 42. So basically it's supposed to be minus 80 plus 100 sine 42 cosine 42 plus minus 60 and then multiply by cosine cosine 42 squared minus sine 42 squared. Yeah, so it's minus 95.8 minus 95.8 megapascal. So this is the correct answer. So what are we trying to do? All what we are trying to do is that we are trying to um find the principal stresses. So we want to get this one and then this one. Okay, that's all. But if you also take, so you can also take CD and do the same thing. If you take CD, you get the same thing, but then it's just that so it's just a formula work. Just know the angle theta and then know how to swap it. Okay. Do you have questions up to this point? Any question up to this point? Any question up to this point? Please, any questions? So the principal stress is like something like a formula work. It's actually all about formula work. Any questions, please? Because that's the answer. Okay. Please, guys, any question? I just want to know if you are following or not. So I'm just asking questions. Okay.